Alright, let's try another question. Now, this one requires you to find the exact value of tangent A given that tangent 2A is equal to negative half and A is a acute angle. Wow, A is an acute angle. Then let's just analyze a little bit. If A is in between 0 and 90 degrees, 2A must be in between what? Oh, don't include the equal sign. Strictly less than 90, strictly more than 0. If you double it, it will become between 0 and 180 degrees. So it's either Q1 or Q2. Then in that case, it's a negative angle. Remember, add sugar to coffee. Only in quadrant 1 and quadrant 3 tangent will be positive. Then quadrant 2 and quadrant 4 tangent will be negative. In this case, we know that the 2A is in between 0 and 180 degrees. And also, we know that the tangent 2A is a negative half, which is negative. Negative means it can only be in quadrant 2 or quadrant 4. The intersection, the only case where both are true, you're in between 0 and 180 degrees, which means you're either Q1 or Q2. But you're negative, which means you're in Q2 or Q4. In order for both cases to be true, you must find an overlap, which is Q2, the overlap. Which also means, conclusion, 2A can only be in quadrant 2. Overlap. Okay, good. So what does this mean now? It's because, okay, let me just write down a short note. Tangent of 2A is less than 0 because tangent 2A less than 0. Yeah, that's why 2A is in Q2 or Q4. Okay, so 2A can only be in quadrant 2. So that's a useful tip to know, just to keep in mind. Is it useful at all? Maybe later, but we'll just figure that out later. But anyways, what I need you to know before you even begin is that there is an identity about tangent of A plus B, okay, regarding tangent of A plus B. Okay, tangent of A plus B is really just tan A plus tan B, all divided by 1 minus the tan A tan B. So this is the identity. Of course, there's an equivalent for the minus sign, but it's not relevant to discussion yet, I think. So, if you replace the B with a, what do you get? You get A plus A, right? If this B becomes A, you get A plus A. What is A plus A? A plus A is just 2A. Okay, it's just 2A. So what does that mean? It means that this B over here replaced with a. This B over here replaced with a. Whoa, that's interesting. What do you get? 10A plus 10A. 2 10A. 1 minus 10A times 10A. They're the same thing. So 10 square A. So that is the double angle formula for tangent. But what's so useful about this? What's so useful about this is that let me just copy down the question. They give us tangent of 2A is equal to negative half. Okay, let me just bring it down. Okay, and let me just draw a line to separate my working. Now tangent 2A is equal to negative half, but we also know that we have this identity. How can we make use of this identity? Very simple. We just have to replace this one with that guy. This one with that guy. So very simple. All we need to do is to copy, paste, and replace. Copy this part, then you replace the left hand side. Wow, isn't that great? We managed to convert our 2A into 1A. Why is that great? Because that's exactly what the question wanted us to find. Tangent of 1A. Okay, so good. Now that we have found expression purely in terms of 1A, we can solve for tangent A. Then you notice, wow, tangent square, so it's a quadratic in form again. Quadratic in form. In other words, it's a quadratic that's not in terms of x. Like usually you see x squared plus 5x minus 10 equals 0. I'm not sure if you can solve this or not. But anyways, okay, let's just make it minus 1. Yeah, so, or plus 1. Yeah, anyways, so what you usually see is a quadratic in terms of x. This is called quadratic in terms of x. This one, when I talk about quadratic in form, in the form, means that the format is the same as a quadratic. You see, there's a something square, there's a number in front, a negative number, but it's not exactly the same yet because the quadratic term is in the denominator. So what we have to do is we have to multiply or flatten out the fraction times, because remember our math students don't like two things: fractions and negative numbers. So try to remove them as soon as possible. I see this thing, I see two things I don't like: fraction, half, yuck. I see negative sign, I also don't like, yuck. So somehow I need to try to reduce the number of negative numbers and fractions I have as soon as possible. If not, I will get confused. Okay, so one way I could do this is I can multiply both sides by negative 2. Negative 2. Okay, what does that do to my negative 1 half? It makes it into a positive 1. How about my left side? If I multiply by negative 2, I'll get negative 4 tangent A. Oh no, there's a negative sign. But no choice, no choice. We have to deal with it. But never mind, because we did the negative sign at the top. Right now, the right hand side has no more negative sign. It's easy to work with. What's so easy about it? What's so easy is that, okay, let me just get rid of this. What's so easy is that we can look at 1 minus tangent square A and times over. 1 times 1 minus tangent square A. Don't need to think. It's just 1 minus tangent square A. What do you get? You get the numerator minus 4 tangent A equals to 1 minus tangent square A. Okay, looks promising. We are flattening everything out. There's no more fractions, but I still see a lot of negative signs, especially this minus tangent square A. At this stage, maybe it would be smarter if I make a clever substitution. I let capital X equals to tangent of A. A previous video I did something similar. So what I'll get is minus 4x is equal to 1 minus x squared. Can I make it in? So now I have a quadratic, right? X squared. Quite obvious already, right? It's a quadratic in form. Of course, this is a capital X. I'm not using curvy X. I'm using a capital X, which represents a tangent of capital A. Later on, we need to substitute the capital X back with the tangent A in order to solve for A. Just a reminder. Okay, but anyways, I see negative sign in front, right? I don't like, because I don't like negative numbers, especially in front of my quadratic terms. I'm not used to it. I don't like it. So what I will usually do is I will just bring it over to the other side and make it positive. In other words, I will get x squared, negative x squared bring over, then minus 4x stays the same, plus 1 bring over become minus 1 equals to 0. Good, I have a quadratic now. Then I will just use my handy dandy calculator to go and calculate my x. What I'll get is a long string of numbers. Maybe if I wanted to be extra precise, I can just calculate. I can just get the exact value by using the quadratic formula. But I've already shown that in a previous video, so in this case, I will just simply take the calculator value. I will have x equals to negative 0.2360679, and I can just stop there. I truncate at 5 decimal places. No, n? No, it's not n, it should be a or. Very different idea. What n means is that your solution is both this guy and the other guy at the same time. What's the other guy? Let me just write that down first. 4.23606. Yeah, what if you write down n in a quadratic equation and you're trying to solve it, you write down n, it means that my solution is both negative and positive at the same time. How can that be? It's not possible. So that's why you have to put or. Or means it doesn't have to be both. It could be one. It could be the left guy but not the other. It could be the right guy. It could be the right guy only and not the left guy. Or maybe there's a chance it could be both. But in this case, definitely not. You can't be both positive and negative. You can't be two different numbers at the same time, right? A solution. But your solution could be one guy and not the other, or it could be the other guy and not the first guy. In terms of set notation, if you've learned it already, it means this is A, this is B, we are looking at this guy, this left side, or or you could be looking at this side here, where the circle representing A is a set that represents the possibility that the x is a negative 0.2306. Then B means it's a possibility that it's 4.230606. The intersection here is impossible. There is no intersection. So the diagram, more accurately speaking, should be A and B inside a universal set. Universe. Okay? Can? Okay, this one maybe E max, but don't need to know so much in detail. But anyways, so make sure you remember to put OR. And anyways, are we done? Yay, we solved for x already. Are we done? No. Why? Because x is actually tangent A, and we are trying to solve for A. So let's just copy that down. Substitute the x with a, sorry, I should have be consistent and use capital X. I use a curvy x just now. But okay, be consistent, right? Have to be consistent. 4.23606. Now, is there a problem? Oh, this one is like, it's like more than 1, you know? Like, I remember there's a rule, right? Something like, if it's more than 1, less than -1, then you cannot solve for the angle in a periodic function in sine, cosine, tangent. Right? Is that right? Wrong. That rule only applies to sine of, like, for example, not relevant to the question, sine of A equals to 1.1, something more than 1. Then no solution. This one is no solution. Why? Because look at the sine curve. Where's the maximum? Where's the minimum? Every single time. The maximum, minimum, maximum, minimum. Y equals to 1, y equals -1. There is no part of the graph that goes above 1. This part here and this part below is empty, meaning that you cannot sine of A equals to something more than 1, meaning that you're trying to find, if you are trying graphically, what this means is that you have a y equals sine A and you have a y equals 1.1. So you have your x-axis, your y-axis, then you draw a solid line, y equals to 1.1. Then you draw a solid curve, sine A, over all the possibilities, and then you try to find any point of intersection and find the x-coordinate of that point of intersection. But in this case, there isn't any, so that's why there's no solution. They don't intersect. Graphs don't intersect. Graph never intersect. It just so happens. Another example would be like sine of A equals to -1.5 or something. As long as it's more than 1.1 more than 1 or less than 1, you cannot solve it. Because the sine and cosine curve maximum is 1, minimum is -1. -1, +1. Okay? Wow, that's a very ugly -1. Oh no. Yeah, oops. Wrong position. Somewhere here, -1. 1. Okay? And same thing for cosine. Cosine also. All these have no solution. No solution. Cosine of something like +2, also no solution. However, that's only for sine and cosine. For tangent is a different case. Different case altogether. Look at its graph. It goes, here's -π/2, here's π/2, x equals π/2, x equals -π/2, and it goes on forever. Plus 180 degrees. X equals pi plus π/2. And then you can have something on the negative side as well, but I'm not going to draw it. X here, y here. How does the graph look? It goes all the way from origin. It goes all the way down, all the way. From here, it goes all the way up, all the way. Same thing here. Then you repeat down from all the way negative infinity, all the way at the bottom, until you reach the x-axis. You cut, and then you slowly increase, and you get faster and faster. You go up towards the other vertical dotted line. These vertical dotted lines are called asymptotes. Asymptotes. You also see them when you are trying to draw like y equals to ln x. Y equals to, let's say, log x, ln x, ln x. Ln x will always pass through 1 comma 0, but then there's an asymptote here, x equal to 0, the y-axis. You cannot plug in, the x must be strictly more than 0. Cannot be 0, cannot be negative. Oh? Yeah, right? So that's why there's a asymptote at x equals 0. Same thing here for the tangent curve. You also have asymptotes at x equal to negative pi by 2 and positive pi by 2, and everything basically plus some pi. From pi by 2, you get plus pi, and then you plus minus multiples of pi. Those are your asymptotes for your tangent. But in this case, notice that that's not the asymptote is not the main point, but the main point is that this curve, it goes down all the way, which means that it covers every possible value, which means that if you try to draw this one, you can interpret as y equals tangent a, y equals 4.236, then y equals tan a means you draw this yellow highlighted curve, y equals 4.23 means you draw a horizontal line, y equals 4.23. Then you try and find an intersection. I found one here, I find the corresponding x-intercept. What is that intercept? That is your answer for your angle A. That is your answer for angle A. But in this, so definitely, because the yellow color curve, it goes up, it goes all the way up, it goes all the way down, with the yellow color curve being the tangent curve, which means that no matter where you draw that horizontal line, no matter what is this value here, doesn't matter whether it's more than 1, doesn't matter whether this value that's 4.236 is less than -1 or anything, it will have a solution for the A. Okay? Alright, so now let's continue to try and solve it. How to solve tangent A equal negative 0.23606 and tangent A equal 4.23606. Okay, I won't spend so much time, I'll go faster this time. Tangent A is a negative value, so we will want to find basic angle, also known as reference angle, also known as alpha. It's just tangent inverse of the positive guy. Throw away the negative sign. But do you need to write this? Actually, I would say you don't need to write this. Just type it in your calculator. Let me just double check out with the question. They wanted us to find in terms of degrees, because you see degrees here. Degrees. So it means that we will just use our calculator in degree mode. Okay, just make sure you're in degree mode, and then you go and type in tangent inverse of the positive version of that number. So positive 0.2306. What do you get? I got 13.28209 degrees. Okay, approximately. Okay, but then tangent A is negative in this case. Tangent A is negative. Now, that's when you should pause for a while and look back at the question. Or look back at the beginning and the conclusion that we made about A. What's A? In between 0 degrees and 90 degrees. So it means it's Q1, Q1. Then what does that mean about the tangent of A? Can it be, what's the tangent of A now? Okay, maybe I didn't write down. So tangent of A, quadrant 1 angle, definitely the sign must be positive, correct? Yes, positive. So look back here. Tangent A is negative. Does that make sense? No. So actually straight away I shouldn't have done this. I should have just checked directly. Reject. No solution. Okay, no solution. Why? Because tangent A has to be in between, angle A is between 0 to 90 degrees, which means that the tangent of that angle must be something that is positive. Quadrant 1, ASTC, it's in A. All of them are positive. Sine, cosine, and tangent are all positive. So this one, negative, is wrong. Cannot. So that means we are only left with this guy, and we try to solve it. Okay, so now in this case, we try to find the basic angle. Let's try and find the basic angle. What would it be? Again, you will just type in your calculator, tangent inverse of, what is it this time? 4.236. 4.23606. And what do you get as the angle? I got 76.7174 degrees. But of course, this is an approximation. It's not exact. We never write down everything. So now what we have to do is to try and solve for A, knowing that this guy is in quadrant 1. Oh, wait a minute, basic angle is the quadrant 1 angle. So therefore, we only have one solution. A is 76.7 degrees 1 dp. Right, I rounded off already. 1 is like between 0 to 4, so I round down. So plus 0. 7 plus 0 is just 7. So 76.7 degrees. And we are done.